Hello guys, here we'll be discussing a concept called asymptotes. Asymptotes is it's a lines drawn to the curves. For example, we know that how to draw a tangent. Basically, look at it. This is if I have taken this x and y axis. If this is my curve, I can draw a line through the particular point on the curve. Okay, on the point. So then this is called a tangent. So similarly, there is a concept called asymptotes here. Asymptote says that a line is called an asymptote to a curve if the perpendicular distance from the variable point P, which is on the curve, is point P on the curve tends to the zero, where our point tends to the infinity. Okay, look at it. The definition says that a line is called asymptote to a curve if a perpendicular distance from the variable point P tends to 0 as the point P tends to the infinity. So look at draw. So this says that we have the x-axis and y-axis, the origin. Okay. So now what will be there? I have a curve. This is a curve and the point P, a variable point P x comma y I have. So it's a line that it's an asymptote, that's a line that it is drawn to the curve where the perpendicular distance from the point P on the particular curve, point P to the particular line, it must tends to a 0 where this P tends to the infinity. Get that? So that means we can imagine that there will be a point that can be come to close to the given asymptote line, given line comes to the drawn line, but which never happens there. So this is the definition of asymptotes. Now types of asymptotes here. One is called asymptotes parallel to the coordinate axis. You get that? For example, will be this case. See, this is x-axis, this is y-axis. The asymptotes will be parallel to y-axis, parallel to x-axis will be there. And asymptotes not parallel to the coordinate axis, that's called a oblique asymptotes. So to find oblique asymptotes also we must get the parallel asymptotes to the coordinate axis also. So now let us see some problems on finding asymptotes which is parallel to the coordinate axis and the problems on oblique. Yeah, now look at it. The given curve is x square y square equal to a square into x square plus y square. For this curve, I need to find the asymptotes parallel to the coordinate axis. The first type of problems here. The first what we are going to do means consider the given curve x square y square equal to, and let me simplify this, a square into x square plus a square into y square. Get that? Now take everything to the left hand side. X square y square minus a square x square plus minus a square y square equal to 0. Parallel to x axis. Parallel to x axis. For coefficient of highest term of x here. So what is the coefficient of highest term of x here? First I need to find what is the highest term of x here. What is the highest term of x? X square. So try to take x square out common. So in that case comes means if I take x square common, I will be getting as y square minus a square y square equal to 0. Is it clear? So first I am going to find parallel to the x axis. Further what I am going to consider? I am going to consider the highest term of x. What is the highest term of x? X square. So I am considering the coefficient of the x square. So what is the coefficient of x square? Y square minus a square. So that one I need to make it equal to 0. So my coefficient of x square is y square minus a square. That must be equal to 0. Is it clear? So this becomes y square equal to a square, y equal to plus or minus a. So now I found the asymptotes parallel to x axis. Now second one, asymptotes parallel to y axis. In this case, I need to consider the coefficient of highest term of y must be equal to 0. So here the case comes in, let us take this equation. If I consider as it 1 after simplification, I will be taking this as it is x square y square minus a square x square minus a square y square equal to 0. In this case, let me combine the y square. Let me take the common y square here. So if I take y square, what will be there here? X square minus a square will be left out. Minus x square will be as it is formed. So in this case, what is the coefficient of y square? Highest term is y square. So coefficient of this x square minus a square, this must be equal to 0. So now for next calculations, x square minus a square equal to 0. X square equal to a square, x equal to plus or minus a. So x equal to plus or minus a for asymptotes parallel to the y axis. Y equal to plus or minus a asymptotes parallel to the x axis. I have x, y, x negative dash, x dash, y dash is negative. This is origin. Okay. So asymptotes what you got here. This is look like x equals, see, I am going to draw first asymptotes parallel to the x axis, y equal to plus or minus a. That becomes y equal to plus a, y equal to minus a. It will become like y, this is y, right? This is y axis, y equal to 0, y equal to a somewhere. This will be y equal to a. You get that? And now y equal to minus a. So y axis, negative axis will be there, y equal to minus a somewhere it will be here. Get that? Y equal to minus. Now parallel to the y axis, x equal to plus or minus a. See, y equal to a, y equal to minus a is parallel to the x axis. You know the definition of parallel and perpendicular, right? So now x equal to plus or minus a I need to draw. X equal to plus a somewhere here. Starts x equal to a. So x equal to a. And x equal to minus a comes in x negative axis. So these are the asymptotes what we got these are the asymptotes for the given coordinate axis. Now our curve will exist inside this, the square, inside the asymptotes. So by this we can say that asymptotes are the boundaries for the given curves here, which is not going to touch the curve limit. Asymptotes to the parallel to the axis, asymptotes parallel to the coordinate axis. Again, second problem considering here x square y minus 3x square minus 5xy plus 6y plus 2 equal to 0 I have here. So now here what we are going to do, first we need to find asymptotes parallel to x-axis. Parallel to x-axis. For that what I need to consider? I need to consider the coefficient of highest term of x that should be equal to 0. You get that? So now first group the terms. Take x square common. It becomes y minus 3. Coefficient will become y minus 3 x square minus, as it is I don't have anything highest term is x square only. So that's why I group the x square terms. So I take an x square out. So I will be getting y minus 3. Remaining 5xy plus 6y plus 2 will be remain as it is, because I can't consider this because x and x square I have here. In that I have highest term is x square here. So in this case I need to make it y minus 3 equal to 0. So y equal to 3. One asymptote what you got it. Now for the parallel to the x axis here. Second one, asymptotes parallel to y axis. Is it clear? So now for this what I need to consider? I need to consider highest term of y and the coefficient must be equal to 0. I must make it equal to 0, not must be equal to, I should make it equal to 0. Now highest term of y is y only. I don't have y square, y cube, I have only y. So what I am going to take mean, I am going to take the y common here. So when I take y common here, what will be there? X square minus 5x plus 6 into y. Is it clear? Minus 3x square plus 2 equal to 0 as it is remain here. Okay. So now what will be the case for me? Now I need to consider the coefficient of y. X square minus 5x plus 6 is equal to 0. Now look at it, it's a quadratic equation. Need to solve it. So when you solve this on simplification, x square minus 3x minus 2x plus 6 can be written. So take x outside. Factorization I am doing that. X minus 3 will be, and minus 2 if you take outside, x minus 3 equal to 0. So here again x minus 3 is out, common, x minus 2 equal to 0. So from here x equal to 3 and x equal to 2 are the two asymptotes which are parallel to the y-axis. Therefore, we got totally 3 asymptotes now. One is parallel to the x-axis, that is y equal to 3, and remaining 2 are parallel to the y-axis, that is x equal to 2, x equal to 3. So this way we can find the asymptotes which are parallel to the coordinate axis.